Assalamu alaikum wa rahmatullahi wa barakatuhu. I hope everyone is doing well. I am Mira Al-Banna from University of Sharjah. And today I will be talking about our project, which is Hybrid Electrical Storage System for RC planes. I worked on this project with my friend Maryam Al-Marzouqi under the supervision of Dr. Ali Radwan. So in the introduction, I would like to put emphasis on something. Airplanes are currently the fastest means of transportation ever, and this contributes significantly to the large amounts of carbon dioxide that accumulate in the atmosphere. This is the main reason for global warming, and the global warming and also the pollution will increase as the amount of aircraft will increase. Therefore, our project's aim is to find a long-term sustainable way that will put an end or at least reduce the amount of CO2 in the atmosphere. Why are we doing that? 2.1% is only from airplanes. So by that, we are at least eliminating the 2.1%. And here I have some of the well-known and most dangerous effects of CO2 on the environment. It causes climate change by trapping heat. It contributes to respiratory diseases. It increases the chance of wildfires and poisons agricultural areas. So by our idea, as I previously mentioned, we will eliminate the 2.1% of the CO2 generated from airplanes. We will have less CO2, which will give us a healthier life for people. And by that, we are also contributing in the era of modern aircrafts. How can we do that? By powering aircrafts with a hybrid electrical storage system, which is composed of two things, a supercapacitor and a hydrogen fuel cell. So the fuel cell takes care of the flight and the cruise, the level of the flight in the sky and the cruise, where the supercapacitor will supply the energy needed for power for the intensive takeoff. So takeoff is the most intensive part of the flight journey. That's why we are using a supercapacitor. Also, the design of the aircraft is selected based on some aerodynamic analysis. Here's our aerodynamic analysis. We have a key right here with which will explain this picture. So the red part is the motor, and we have the dimensions right here for each part. In this box, we can see the total weight in grams, which is 1,216.4 grams. Right here, we see pictures. Using this software, AeroSim RC, we were able to simulate our aircraft in Sharjah virtually. And actually it worked. As we can see here, the aircraft is flying in the speed of Sharjah wind right here in the sky. So our aircraft was successfully working. Right here we have a business model that explains our project in details. So our value proposition, we produce zero CO2 and we produce a sustainable, healthy environment for people. Less noise pollution, since fuel cell and supercapacitor does not produce sound while operating, and this will reduce the noise pollution and it will give a relaxing flight for people. More job opportunities for sustainable renewable energy engineer. And by that, I mean to tell people that sustainable renewable energy engineering, it's not only about solar, wind, hydro, and geothermal. We're actually creating sustainable opportunities and conserving energy to maintain a green and healthy world. This is our main job. So in key activities, right here, we see the equation, and it's one of the main ideas of fuel cell. So this is the equation of any galvanic cell. Fuel cell is a galvanic cell. We notice from the equation that we will have water, electricity, and heat in the reactant. So these reactants will be only produced when we implement our idea on a large scale. So for such a small aircraft like the one we did here as our prototype, it will not produce any of the following. Okay, so these only take place on a large scale. So we can actually also benefit from them on a large scale. We can use the excess heat to generate electricity that will be used in the aircraft sockets, and water will be used for cooling and electricity generation. Actually, reusing the waste will increase the efficiency of the aircraft. Our key partners, so we need green hydrogen from the solar park to supply our fuel cell. We need DEWA for electrical powering. We also need a General Civil Aviation Authority to give us an acceptance or a permission to test our prototype in the sky. And we need a fuel cell store to purchase our fuel cell equipment. Customer segments, we need contracts with airports, with manufacturers, with aircraft manufacturers. And our resources, as mentioned earlier, we need hydrogen for the fuel cell and electricity. So right here we have a table, and in this table we see the items we need for the fuel in general, for everything, for the whole aircraft. So the price for the prototype would cost 3,297 dirhams, and in the table we can see each item, the quantity needed, and the total cost, and the store or the shop. And in this table we see the power. Okay, so the power needed or supplied to each of the following, and total power is 632.04 watts. So our customer relations, we need to do relationships with aircraft companies, boarding passengers, and Ministry of Climate Change and Environment. Channels we need are transport and communication channel and environmental channel. Finally, we have reached to our SWOT analysis. So the strength of our idea is that we produce 0% CO2 emissions, and this will result in a healthy environment for people and residential areas around the airport. This will also need less maintenance complexity and a longer lifetime for the equipment. Our weaknesses is the price of the jet fuel and hydrogen. Now, this isn't much big weakness. It's actually the price of hydrogen now is less than it was 10 years ago. So, and it will continue to decrease. So this weakening point can be resolved by time. Now, opportunities we create opportunities for aircraft manufacturers, research and development association, because our idea is an interesting field for research. Now, threats, storage of hydrogen, flooding of water might occur in the fuel cell, drying might occur in the fuel cell. Now, regarding these 2 points, drying and flooding can be solved by heat and water management. It can be easily solved by heat and water management. We just mention them to keep them in mind, but they're not much big of a deal. The only threat is the storage of hydrogen, and by doing more research on this point, we can actually find effective ways of storing hydrogen. By that, we have reached to the end of our research. Thank you so much for listening. If you have any question, please don't hesitate to contact us. This is my email, and this is my friend's email, Mariam Al Marzouqi. Thank you so much for listening.